Solving question number 19, we have two trig functions in a single equation and neither of them are squared. To me, that's a key to use a strategy where we square both sides. But before we square both sides, we want to make sure we get your trig functions isolated. I don't want both of these trig functions on the same side, because if I square them, I'll get a cosecant squared, I'll get a cotangent squared, but I'll have a plus 2 cosecant cotangent. And I don't want, either x's, I don't want that middle term sitting in there. So that's kind of messy, but that's the reason I want to isolate the trig function. So I'm going to have 1 minus cotangent of x on the right. Now I'm going to square both sides. So squaring both sides, this is going to create a Pythagorean identity, because we'll have a cosecant squared of x equals 1 minus 2 cotangent of x plus cotangent squared of x. When you start collecting our like terms, well, before I collect like terms, this cosecant squared of x is a trig property or trig identity of cotangent squared of x plus 1 equals 1 minus 2 cotangent of x plus cotangent squared of x. The ones will reduce, so if I collect them, I can subtract 1 from both sides. The cotangent squared will reduce, I can subtract cotangent squared from both sides. So 0 equals a negative 2 cotangent of x, which means if I divide both sides by a negative 2, I still get 0 equals a cotangent of x. Now I'm looking for an angle whose cotangent value has to be 0. So I got to be thinking of what the meaning of cotangent is. Cotangent is your x values over your y values. The only way I get an answer of 0 out of this is if the x value is 0 and the y value is not 0. So whatever this is, I don't care. It's going to be a 1 or a negative 1 to equal 0. So I'm looking for where x's are 0. X's are only 0 at pi halves and 3 pi halves. So these are our two possible solutions that we could use. So now I'm going to take and make sure that I check both solutions, because this is the one warning that they told us. Anytime you use that strategy of squaring both sides of the equation, you have to make sure it works back in your original. So these are going to get plugged back into the original to make sure that they work. So we're going to take the cosecant of pi halves. Cosecant of pi halves are your y values. Your y values at this ordered pair are 1. So it's going to be 1 plus. Then it says take the cotangent of pi halves. So I'm still at this angle of pi halves. The cotangent is x over y, so that's 0 over 1. Which is 0, and 1 plus 0 is 1. So I know that pi halves works. I check it. It's going to be okay in my solution set. I also have to check the other solution, which was 3 pi halves. So I'm going to put in 3 pi halves for the cosecant. So this order pair is 0, negative 1. So I need to put in a negative 1 for the cosecant of x, because cosecants harvest y's. Then I need to do the cotangent of 3 pi halves. So again, that's going to be 0 over a negative 1, so then I'm looking at negative 1 plus 0. Is it equal to a 1? No, it's not. So I disregard that solution and take it out of my solution set. So in the end, I want to throw out the 3 pi halves, and my only solution in my solution set is pi halves.